Hello students, welcome to my channel Experience Physics, and this video lecture is all about solving kinematic equation. This is coming under the chapter Motion in a Straight Line. This is all about calculation of distance, velocity, acceleration, and of course time also. Wait. So this is a continuation of another video in which I have solved 15 numericals for the calculation of distance, velocity, acceleration and time using kinematic equations, right? If you are interested, you can watch that video also. Its link is given in the description box, right? So this video lecture is about the problems involving both acceleration and deceleration, right? So a particle is moving along a straight line. If both acceleration, after some time deceleration is acting on that particle, how to calculate the distance traveled by the particle, as well as what is the total time of journey, what is the average speed, what is the maximum speed. These are all the things what we are going to see in this video lecture. If both acceleration and deceleration are given in the problem, what to address them, right? Acceleration, let us use the letter alpha, and for deceleration let us use the beta, right? So we used to write acceleration using the letter A, right? If acceleration is given, we will use the letter A. If deceleration or retardation is given, we will include the negative sign. But instead of using plus A and minus A, let me take two different symbols, alpha and beta, right? So let me draw one graph, velocity versus time. This is velocity and this is time. A particle starts from 0, that is at rest, and its velocity is increasing because of some acceleration up to some time interval, say t1 second, then it starts to decreasing. This is t2 seconds, right? This is because of deceleration, right? The particle is at rest at this point, velocity is 0, then it starts to increase. The speed is continuously increasing. At this point, say this is maximum speed. It attains maximum speed at t1 second. Then the driver is applying the brake. Assume this is a car or vehicle. So it is increasing. After some time, that is after t1 second, the driver is applying the brakes. It starts to deceleration. Then it is again reaching the 0 speed, 0 velocity, right? So this is the maximum, Vmax, maximum velocity. This is the time interval t1 second and t2 second. Some distance it is also traveling. Right? Total time, let me write it as capital T, total time. So T is equal to T1 plus T2. So let us find T1 and T2 separately using the standard equation. V is equal to U plus AT. So in this case, since U is equal to 0, AT will be used for us to continue the derivation. V is equal to AT since U is equal to 0. Since U is equal to 0. So starting from rest, V is equal to AT, right? So T1, V max, this is the final speed, V max, this is final speed, it is initial speed, V max is equal to alpha into acceleration, we have considered it as alpha, the letter is alpha, T, it is T1, time. So T1 is equal to V max by alpha. This is equation number 1. Similarly for deceleration, this is 0. 0 is equal to, final speed is 0, initial speed is V max. Initial speed is V max plus beta into T2. Since it is deceleration, let me write it as minus beta. Deceleration, right? So V is equal to 0, U is equal to V max. This is the initial speed when the deceleration is working on. Right? So T2 is equal to V max by beta. This is minus sign, so you can take it to the left hand side. So total time is equal to T is equal to T1 plus T2. T1 plus T2. T1 V max by alpha. T2 V max by beta. So this is V max can be taken outside 1 by alpha plus 1 by beta. This is T. So I want to write it in this format. In this format I want to write. So that means V max I want to velocity I want to take to the left hand side, time I want to take to the right hand side, right? So this is T is equal to V max of 1 by alpha plus 1 by beta. So V max is equal to, or let me simplify before it. V max of, this is LCM, alpha plus beta. This is T. So V max is equal to T divided by alpha plus beta divided by alpha beta, or T of alpha beta divided by alpha plus beta. So this is V max. V max is equal to, if you compare this equation with this one, V is equal to A into T. So V max is equal to, instead of A we are having alpha beta divided by alpha plus beta. Instead of small t we are having the capital T. Yes. You compare these two equations. Instead of V usually under kinematic equation we have studied as final velocity, but here it is maximum velocity, this point. And this is A, but it has both acceleration and deceleration. Alpha beta divided by alpha plus beta. It is small t, but it is capital T. That indicates it is a total time of journey for both acceleration as well as deceleration, right? So this alpha beta divided by alpha plus beta, this term is usually called as combined acceleration. Alpha is acceleration, beta is deceleration, so this term is known as combined acceleration. Combined acceleration. Alpha beta divided by alpha plus beta. So this is total time of journey. This formula is very useful for us to solve some more problems which are coming. So this is V max is equal to alpha beta divided by alpha plus beta into T. It appears as V is equal to 0 plus AT. 0, I have not written here 0, so it is starting from the rest. So V is equal to 0 plus AT, it is V max is equal to alpha beta divided by alpha plus beta into T. So this is combined acceleration. Similarly, we can write S is equal to UT plus of AT square. So this is the total time of journey. This is total time of journey. What is the distance covered during this time? Distance covered during this time. This is as usual 0 because it is starting from rest. Of into A is combined acceleration. Alpha beta divided by alpha plus beta. Instead of A we are writing combined acceleration. Instead of T we are writing T square. So this is the formula for the total time of journey. So two formulas we have developed for this case. If both alpha and beta, that is acceleration and deceleration, are given, the maximum speed, this one, AT, the distance covered of AT square. But please remember the T is a capital letter, total time. Similarly, this is combined acceleration. A car starts from rest on a straight road first. The acceleration with 6 meter per second square, then suddenly decelerates with 3 meter per second square. Alpha is 6 meter and beta is 3 meter. Alpha value and beta value are given till it stops, right? Till it stops. If total time of journey is 10 seconds, then the maximum speed acquired by the car is what? V max has been asked. Alpha is equal to 6 meter per second square. Beta is equal to 3 meter per second square. Total time of capital letter T, 10 seconds. Then what is the maximum speed? Yes. What is the maximum speed? V max is what? Right? Our formula is V max is equal to 0 plus AT, U plus AT, that is 0 plus AT. A is equal to alpha beta divided by alpha plus beta into T. Alpha is 6, beta is 3, then this is 6 plus 3 into total time of journey is 10 seconds. So this is 80 by 2 into 10. This is 9. 18 by 9. So 2 into 10, 20. The answer is option D, 20 meter per second. Next problem, a cycle accelerates from rest at a constant rate of 2 meter per second square for some time. Then it retards deceleration at a constant rate of 4 meter per second square. Retardation is 4 meter per second square and comes to rest. Okay. If the total distance traveled by it is 6 meter, S value is 6 meter, then time of journey is asked. Alpha is 2 meter per second square, beta is 4 meter per second square. The distance, total distance is 6 meter, then total time of journey is what? See, we have the formula, where is it? S is equal to 1 by 2 of combined acceleration into t square. S is equal to, so usually we will write ut plus of at square. So this is made as 0 because it is starting from rest. So of at square of combined acceleration is alpha beta divided by alpha plus beta. This t will be capital letter T. Yes, this formula is used here. 1 by 2, S is given. S is equal to 6 meter. So 6 is equal to 1 by 2 of alpha 2 beta 4. 2 into 4 divided by 2 plus 4 t square. So the 2 is cancelled. So this is 4 by 6 t square. 6 is equal to 4 by 6 t square. So 4 t square is equal to 6 into 6. T square is equal to 6 into 6 divided by 4. So this is 2, this is 3, this is 2 and this is cancelled. So this is 3 into 3 is t square and t is equal to 3. 3 seconds is the answer, option A. Next problem. A car starting from rest is accelerated at a constant rate alpha until it attains a speed v. It attains a speed v. So this is accelerated by alpha until it attains a speed v. That means maximum speed is given as v. It is then retarded at a constant rate beta and comes to rest. Average speed is what? This is time and this is velocity. What is the average speed? The question is to find the average speed. This is the maximum speed, right? So we have the formula for maximum speed. Vmax is given as V is equal to U is 0, initial velocity, A combined acceleration, alpha beta divided by alpha plus beta t total time. So this is the maximum speed, or V is equal to alpha beta divided by alpha plus beta into t. But the question is average speed. We average, from the fundamentals we know, the formula is total distance traveled divided by total time taken. Average speed is written as total distance divided by total time. This is S and this is T. S, already we have developed the formula. S is equal to half combined acceleration t square. So this is half combined acceleration then t square divided by this t. So when t is removed, this is half alpha beta divided by alpha plus beta into t. This is average speed. So if you look at the options, alpha v beta, beta v alpha v, but in our expression t has come. So we have to neglect t here. We have to remove t here to find the average speed, right? So for t, we have developed one more formula. V max is equal to, or V is equal to, V is equal to combined acceleration alpha beta divided by alpha plus beta into t. This is one relation already we have got. So instead of t, we are going to substitute this value. This is V. V is available. Everywhere V is available. So V we can use, right? So V average is equal to half of alpha beta divided by alpha plus beta into t. So t is written as alpha into beta. T is written as V divided by alpha beta divided by alpha plus beta. This is combined acceleration. So this is removed now. So the answer is V by 2. V average is equal to V by 2. Option D is correct, right? So both the formulas are used here. Yes. Next topic is distance covered in nth second versus distance covered in n second. First, let us find the difference. Distance covered in nth second. So this word is singular. Distance covered in n seconds. This word is plural. So nth second. So many intervals we can divide. This is a long line. A particle is moving along this straight line at t is equal to 0, t t is equal to 1 second, 2 second, 3 second, this way. So this is the small distance and this is a big distance, right? So I am going to use two different letters, lowercase s and uppercase s. Distance covered in nth second, lowercase. Distance covered in n seconds, uppercase, right? Let me draw once again the line. At t is equal to 0, at t is equal to 0, then t is equal to 1, t is equal to 2, t is equal to 3, 4, 5, it is going this way. So this is the distance traveled in the first interval, first second. Distance traveled in the second second, third second, fourth second, similarly fifth second, right? So this is what I am going to write it as small s, s1, s2, s3 and s4, and this is capital letter S1, this is capital letter S2, capital letter S3 and this is capital letter S4. What is the difference? So when the capital letter is used for this long line, it is starting from the initial point at t is equal to 0. From here it is starting. All the bigger lines are starting from the starting position at t is equal to 0. But here S2 is starting after the first interval is finished. S3 is the distance after the second interval is finished. Similarly S4, S5, etc. Right? So this is the time, this is the distance travel in this particular instant only, particular time interval. For this particular time interval, what is the distance? For this particular time interval, what is the distance it is covering? So S1 is the distance covered in first interval or first second. S2 is the smaller, lowercase letter. S2 is the distance traveled in the second second. Similarly, third second, fourth second, right? So I want to know this distance. S4 I want to know. What is the distance traveled in the fourth second? Simply this distance I want to know, right? So I want to find this distance S4, I can take these two lines, capital letter S4 and capital letter S3. If I subtract S3 from S4, I will get this green line, isn't it? So S4 is found by subtracting S3 from S4. So this is lowercase letter, these are uppercase letters. So instead of 4, let me write n to make the general formula is equal to Sn minus Sn minus 1. This is what we are going to see next. So Sn, nth interval, what is the distance traveled in the particular interval, right? Sn, what is the traveled in the particular interval? So what is the total distance right from the beginning minus previous interval, Sn minus 1. Sn is equal to Sn minus Sn minus 1. S1 what we can write? So the general formula is ut instead of t, let me write n. T is equal to n here, plus of a t square. T is equal to n. Then Sn minus 1 is equal to u of n minus 1 plus of a n minus 1 square. So we need Sn. Un plus of a n square minus then this is u of n minus 1 plus of a n minus 1 square. So let us expand. Of a n square minus un minus u plus of a, this is n square plus 1 minus 2n. So let us cancel some terms. Un plus of a n square minus un, this will be plus u, this is minus of a, the n square is taken outside, minus of a 1 minus 2n. So the un and un are removed, of a n square minus of a n square. So we will have u minus Sn is equal to u minus of a of 1 minus 2n. So I want to make it as a plus of, so this will be 2n minus 1. This is the formula we need. Distance traveled in nth interval is equal to u plus of a of 2n minus 1. This is one important formula. You please remember this formula for solving next few problems. Right. If a body having initial velocity 0, u is equal to 0, moving with uniform acceleration 12 meter per second square, the distance traveled by it in 8th second, not in 8 seconds, 8th second. So this means s suffix 8 is asked. S suffix 8 is equal to, the formula is Sn is equal to u plus of a 2n minus 1. So u is equal to 0, velocity is 0, plus of into a is 12, 2 into n is equal to 8, 2 into 8 minus 1. So this is 6 of 2 into 8, 16 minus 1 is 15. So 90 meters is the answer. Option B, right? Next problem, if a body starts from rest and travels 120 centimeter, u is equal to 0, s is equal to 120 centimeter. In the 5th second, that means s suffix 5 is equal to 120 centimeter. Then the acceleration is what? S, small letter s, s5 is equal to u plus of first let me write the formula. S suffix n is equal to u plus of a 2n minus 1. So this is 120 centimeter is equal to u is 0, of a is in question 2 into 5th second. So this is of into a into 9. This is 120. So a is asked. So a is equal to 2 into 120 divided by 9. So this is 3 and this is 40. 80 by 3. 80 by 3. Right? Let me write it as 81 by 3. So that we can use 3 table. 81 by 3 is equal to 27. So a value which is less than 27 is the answer. Slightly less than 27. So option A, 26.66. Next problem, a person starts from rest, u is equal to 0 and moves with acceleration a is equal to 5. The ratio of the distance covered in 4th second to that covered in 4 seconds. So this is 4th second and this is the total distance covered in 4 seconds. All the 4 intervals, right? So S suffix 4 divided by S suffix 4 is asked. 4th second, distance traveled in 4th second. This is the distance traveled right from the beginning up to 4 seconds, right? So what is the formula? S suffix 4 we will write it as u, it is 0 plus of, what is the formula? Let me write the formula first. S suffix n is equal to u plus of a of 2n minus 1. So 0 plus of a is equal to 5, 2 into n minus 1, 2 into 4 minus 1. So this will be 5 by 2 into 7. This is S power 4. Then capital letter S power 4. What is the formula for it? For big S, ut plus of at square. From the list of kinematic equation, u is equal to 0 starting from rest, of into a is equal to 5, t square is 4 seconds, 4 into 4, 16. So this is 5 by 2 into 16, S power 4. We need this ratio, small s suffix 4 divided by capital S suffix 4. S4 is 5 by 2 into 7. This is 5 by 2 into 16. So the answer is 7 by 16. 5 by 2 are removed, right? 5 by 2, 5 by 2. 7 by 16. Option C is correct. Next problem, a particle is moving in a straight line with initial velocity u and uniform acceleration a. If the sum of the distance traveled in 10th second and 11th second is 80 meter. 10th second, right? That particular interval only. Yes, 10. Sum of the distance traveled, right? Plus S11 is equal to 80 meter. Then velocity of particle after 10 seconds. So velocity after 10 seconds. This is in question. UA, their values are not given. The distance traveled at 10th second, then the distance traveled at 11th second is 80 meter. What is our formula? S suffix n is equal to u plus of a of 2n minus 1. So S10, first let me write. S10 is equal to, u is equal to, yes, itself u plus of a of n is equal to 10 now. 2 into 10, 20, 20 minus 1, 19. Then S11, u itself of a, 2 into 11, 22, 22 minus 1, 21. If you add these two, S10 plus S11 is 80 meter. S10 plus S11, this is 2u plus of a is common. 19 plus 21 is 40. So this can be written as 20. So 80 is equal to 2u plus 20a. This can be simplified as 40 is equal to U plus A into 20. General formula is V is equal to U plus AT. The question is V after 10 seconds. So 40 is here in the place of V. 20 is here in the place of T. This is, I think this is 10 seconds. Yes, this is a mistake. Yes, now it is right. Instead of V 40, instead of T it is 10. The question is V after 10 seconds. So when T is equal to 10 seconds, V is equal to 40. The answer is 40. We are comparing our equation with the original kinematic equation and we are getting V is equal to 40 meter at T is equal to 10 seconds over. Next problem, starting from rest, U is equal to 0. A body travels 36 meter, S is equal to 36 meter in the first 2 seconds of its journey. So that means it is total distance. So time is equal to 2 seconds. Distance it can travel in the 10th second. S10 is equal to what? It is traveling 36 meter when the time is 2 seconds starting from rest. 10th second, how much it is traveling? So what is our formula? Sn is equal to U plus of A of 2n minus 1. So instead of n, I am writing 10 here. U is equal to 0 plus of A, 2 into 10, 20 minus 1 is 19. So this is 19 by 2A. That is the answer, 19 by 2A. But A value is not known. So from here I have to find the A value from this data, right? So S is equal to UT plus of AT square. U is equal to 0 of A. T is 2 seconds. 2 into 2. S is equal to 36 meter. So 2 is removed. So this is 2A. 2A is 36. A is 18. This 18 is put here. S10 is equal to 19 by 2 into 18. So this becomes 9. So the answer is 19 into 9. 19 into 9. S10 is equal to 19 into 9. 9 into 10, 90. 9 into 9, 81. 90 plus 81 is equal to 171. So the answer is 171 meter. Option D. So this is the last problem of this video lecture, guys. Thank you for watching. All the best.